I know this may be too late, and in any case, I've already posted one MegaFave number, but this one was inspired by Tom Rock's math because it involves the Planck constant without taking the inverse of the Planck constant, although it does involve a denominator. What this number is the smallest denominator for which a rational approximation to the square root of 2 is differs from the square root of 2 by less than the Planck length. Now, that's assuming, of course, that the number line is set up so that the distance from 0 to 1 is 1 meter, but we can make that assumption. And that's the Planck length, 1.616255 times 10 to the minus 35th. And here is how I came up with that number. If we take successive intervals beginning from 7/5 to 17/12, these are all rational approximations to the square root of 2. And since the difference between these is steadily decreasing, eventually we get one that an interval length that's shorter than the Planck length. Now, this is a really beautiful set of sequences. The ones on the left are steadily increasing but never get bigger than the square root of 2. The ones on the right are steadily decreasing and never get smaller than the square root of 2. So even though we can continue these infinitely, all we do is make the interval smaller and smaller. So we have very good demonstrations of the limit, and ultimately we have a neat demonstration of the completeness axiom. Now, the reason that we can say that this number is closer to the square root of 2 than the Planck length is because for any of these intervals, the endpoints are closer to whatever is in the middle here than the length of the interval. And so there's a lot of pretty things about these sequences. The actual interval length is a unit fraction with the denominator being the product of the two denominators. So there's just so many pretty patterns in this that this has become my second MegaFave number, and I'll probably have another one tomorrow.